All right, we're on this last question here, and this is typical of the exam bank questions. Decreasing the temperature of the lube oil, leaving the lube oil heat exchanger is normally accomplished by. So what I've done here is I've given you here's a bearing with a variable heat load, and here's the shaft, and here's oil entering that bearing, lubricating and cooling it, and hot oil leaves, and here's a throttleable valve, and it comes on down to a heat exchanger that has cooling water flowing through it, and so it cools the oil. Now here's cooler oil going back to the bearing. Obviously I would need some pumps and such in here, but I've omitted them for now. So how would it says decrease the temperature of the lube oil. How do I get temperature right here, this temperature, to go down? How do I get cooler oil going to this bearing? First one says increase the cooling water flow rate. So if I open this valve right here and get more cooling water, that will certainly lower the temperature here. For the same flow here, I'm going to put in more cooling water per unit time. That is certainly alpha right out of the gate is a great answer. Let's make sure the other three are wrong though. Increasing the lube oil flow rate. Well, if I increase the mass flow rate of this lube oil right here, it's going to come in and go really fast through this heat exchanger, and the contact time with the cool water, it's it's not going to have enough time to transfer heat. Now, the rate of heat transfer goes up, but that's not what they asked. They asked us what happens to outlet temperature. Since I'm not in contact with the heat exchanger cool fluid as long, I go through it really quick. I don't have time to transfer heat to the cool water. So in actuality, Bravo temperature goes up. Even though the outlet temperature went up, heat transfer rate did go up because Q dot is proportional to mass flow rate, but that's not what they're asking. They're asking temperature. So Bravo is wrong. Decreasing the cooling water flow rate. Well, this is just nonsense. If I took this and closed this valve, I don't have anything going on here, and the hot oil would come on in, wouldn't transfer any energy to the cooling water, and the temperature here would go up. And then we're looking for temperature to go down. Finally, decreasing lube oil flow rate. Well, that was the opposite of what it is. So let's decrease the mass flow rate of the lube oil. So it comes in here really slow, and it comes in here and it has lots of contact time, and ooh, it's getting colder, 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 colder. Yes, you know what? Delta would answer this question. Now here's the kick. Alpha and delta would both accomplish reducing the temperature at the outlet of the heat exchanger. But a key word, it says, which of the following is normally done to decrease the temperature of the lube oil? We don't adjust the flow rate of the oil typically. We normally would adjust the cooling water flow rate. And that's why alpha is right and delta is wrong, because of that normally. If it would have said decreasing the temperature of a lube oil leaving a heat exchanger may be accomplished by, well, this would have two correct answers. But it says normally. So watch out for words like that.